Brumback from the Dell Medical School.
Hi, everybody. I'm a pediatric neurologist here at UT Austin, and I take care of kids who have neurodevelopmental conditions. These common conditions that we talk about, like autism, epilepsy, developmental delays, those are all rare diseases that have a common outcome. And so I do genetic testing in all of the kids I take care of, essentially. And we can find a reason for the person to have their developmental disability in about 25% of kids. But what can we do with that information? That's the problem. That is usually where the conversation ends with the family of me saying, I'll let you know when I see you next time what has happened in the scientific research world. I'll keep you posted. And that's not, that doesn't help with a person's sense of urgency that this is my child who's going downhill. We need treatments now. And so I've been very inspired by many of the parents of children with neurodevelopmental disorders who have forged their own paths to create research for their children and others who have similar conditions. And so one of my patients, Harvey, he came to me with developmental delays. We did genetic testing and found that he had mutation in a protein, in a gene called DLG4. His mom created this foundation called Hope for Harvey. And we've been able to characterize a worm model of Harvey. And I'll show you this video. So on the left side is a wild type worm. They swim in 2D. On the right is Harvey's worm. You can see that it has this, we call it a conductor phenotype, where instead of just swimming in 2D, it's swimming in 3D. And so really, we have gone from genotype to phenotype. And now our next step is to drug screening. And so our goals for this coming year are to initiate that drug screen for Harvey and expand our partnerships with other families, researchers, clinicians, and foundations. Thank you.
Do you already have a list of drugs, repurpose drugs or compounds that you're planning on screening?
So there are several commercially available libraries of drugs. And so we're meeting next month to talk through our options.
And how are you going to be identifying the ones that you want to actually screen?
Well, ones that are not hypertoxic, and then ones that pass through the blood-brain barrier. Those are the top two issues that we're hoping to narrow the list down by.
So it'll be like a high throughput. You'll be looking at a whole lot of compounds.
Yeah, so these worms are about the size of Lincoln's nose on a penny. And so we can have thousands of animals being screened all at once. And so we can go through hundreds of compounds in a matter of 2 to 3 months.
I've been told this is the last question, so I'll be quick. How do we get away from many sort of disease-specific repositories of data and samples to more accessible resources that can be shared across multiple projects?
Explain what you mean.
So I have a son with a rare condition. There are 4 separate, academic and non-academic repositories where you can take his genetic sequence, take information about that disease and put it in, right? And I'm very open. We're very open to sharing that data for research, right? But they're balkanized, right? They don't really share that information among the different groups that are working on it. And so when you're talking about, as you mentioned, in this case, the fact that you've created this model, right? You've identified this mutation. You've now created this model. Yeah, it's a longer question than I meant to ask, so I'm sorry. But how do we start to be able to share that stuff more broadly?
Maybe we can discuss that during.